I would like to attribute this video to shower thinking. For me, and probably other people, showering is a rare, quiet time of the day to let my thoughts thrive. It allows me to come up with creative ideas, like this video. But, I have a problem. Shampoo. Well, the shampoo itself is not the problem, but admittedly, sometimes I forget to put on shampoo when I'm in deep thought, and I'm distracted by if I have already used my shampoo already or not, and that takes precious time away from my shower thinking. So me being an engineering major, I set out to save my shower thoughts. Okay, so if I want to keep shower thinking in peace while also putting on shampoo every time I shower, I will need a device that somehow indicates that I need to put on shampoo. I know, it sounds stupid that I need to have a device to tell me that I need to put on shampoo, but I'm in deep thought in the shower, okay? Who has project ideas and who doesn't? Exactly. Okay, so the idea that I was thinking about, which I thought of in the shower, by the way, just keep that in mind, is one that will use color changing LEDs to let me know that I need to put on shampoo. So here's a rundown of all the components and characteristics that the device could have. These are color changing LEDs, called RGB LEDs. And if you don't know, they are called RGB because they can produce the primary colors, red, green, and blue, at different brightnesses to create a spectrum of colors. I can use red, or perhaps just no light, to indicate that I haven't used my shampoo yet, and green to indicate that I have. The thing is, we need to somehow detect that I've used shampoo. That is where this sensor comes in. Here we have a photoresistor. Its electrical properties change when the light level changes. In this basic circuit, we get more voltage with more light, and the opposite with less light. We can use this to detect if I have taken the shampoo bottle or not, as the light level will increase once I lift it up. If the photoresistor doesn't work, then we have our vibration sensor. Inside of it is a conductive cylinder that electrically connects two ends. If the vibration sensor is, well, vibrated when I put down the shampoo bottle, then the cylinder loses contact with both ends and cuts the circuit. You can actually hear the cylinder rattling inside when it's shaken. So the device needs to be battery powered. I definitely do not want to run 120 volts from my outlet into whatever I made in the shower, because that would be bad. Definitely want battery power, as it means low power, so no danger there. However, I need to conserve the battery capacity of the device to avoid needing to change batteries every few days. So how can we do that? It is simple. Just turn it off when not in use. Well, okay, the answer is very simple, but how exactly do we go about it? I don't want to have to remember to turn it on and off, because then it's another thing that I have to not forget when shower thinking. It needs to know when to turn itself on and off by itself. Introducing the resistance temperature detector. Sounds fancy, but all it does is it changes its electrical properties when the temperature changes. My guess is that as the temperature increases, the metal structure inside expands, and so electrically, it changes as well. It should work, because when you shower, the temperature rises. Similar to the photoresistor, it can be used in a simple circuit to create a voltage to trigger something, in this case, to power on the device. In terms of electronics as a whole, it needs to be in a small form factor, preferably in a printed circuit board. There are a few new things that I would encounter by needing to do this. I would need to use an Arduino chip by itself, which I've never done before. I would need to use some new electronic components, and finally, I would need to design a PCB, which I have not done since 8th grade. So we all know that electronics and water is bad, and we're creating a project, an electronics project, to be put in the shower. So how do we defy the age-old idea? Box. The answer is box. Specifically a box designed to keep water out. The material of choice is PETG, as it is known to be pretty water resistant and is also 3D printable. I'll design that once I get the electronics worked out. If you are enjoying this video so far, consider liking and subscribing. I would appreciate it a lot. Before we make a circuit board that can't be changed and takes time to ship, we need to make sure our concept works with a prototype. This will be our test of the vibration sensor, so here we go. I'm just going to shake this very violently and we'll see on the graph. As you can see, it can detect vibration pretty well. So now it's time to test the alarm clock of the device. The temperature sensor. If this doesn't work, then I'll have to think of another way to turn on the device. There we go. It's kind of spiking, but I mean, we can only receive whole numbers. And now it stabilizes, 541. So let me breathe on it again. Let's see. Yeah, there we go. So it's 542. Let me try and get it higher. It's more consistent. Fortunately, it can detect my warm breath and my hair dryer. But tests in the shower were a wash. No success. It was not sensitive enough. There was also another issue. The temperature sensor is inherently analog, and this essentially means that it would give us basically infinite amounts of different values. That's bad if we want to have it turn itself off to save power. What if it misfires and turns on? What if it was a very hot summer day and it turns on then? I then went into a depression, knowing that I couldn't even make the device turn on and off when it needs to. Absolutely shook my entire world, just like how I shook that vibration sensor. Soaked in sadness, I went into my shower to find quiet time. I enjoyed the water running down my fingers, but then it hit me. Water is conductive. Showers have water in them. Chances are, some of that water can get onto the device's box. I then burst out of the shower. Quickly realizing that I still needed to put on shampoo, I got back in and did my business. Then for real this time, I got out and did some testing. I believe my shower thoughts were helping me because I was trying to help them. There's a voltage regulator where all of the device's power goes through and gets regulated and distributed to all the components. There's also a pin on that regulator that, when it receives a voltage, it turns on and thus turns on every other component. All we need is to have water bridge the connection between two conductive wires so that the battery's voltage from one end can go into the pin of the voltage regulator to turn the rest of the components on. And by the power of evaporation, the connection will be cut after some time. This will probably be the simplest sensor because, not gonna lie, it's just two wires. Okay, so the main components are tested. Now it is time to put them together to make the final design. Let's start with the printed circuit board. It's interesting how PCBs work, even for me who had designed a few before. The board itself is like the landscape to a city. The copper traces that connect the components are like roads. Sometimes they go under and over each other like tunnels and overpasses. A capacitor, which holds some electricity, is like a water tower that supplies water to facilities and buildings. A microchip is the town hall. I wouldn't be able to make all this at home without PCBWay, who provided the services to produce this PCB for this project, and is also the sponsor of this video. Thank you, PCBWay. Now that we have the PCB design, I can take it into the CAD software and design a water tank container around it. The container has two clamping bolts to hold onto the shower handles, and a small reservoir to hold water to bridge the connection between the two wires to turn on the entire device. Finally, there is a lid to allow us to put in the device and then enclose it. Time to fabricate the parts and put it all together. Test it out. Pretty solid for a platform that needs to hold up shampoo. 800 something, right? Now, when I put my hand over it, it's about 600 something. Now we look at the average vibration reading. So when I shake it, it goes down because the metal cylinder inside is losing contact. Okay. Sure hope that this thing is wet, but not you guys. So here we go. Okay. I'm getting wet. I'm definitely getting wet. Oh, there we go. There we go. Just gonna grab this. I'm gonna dry the outside, right? Because we don't want any water to accidentally, from the outside, get in when we open this top. So what I'm worried about are the seams. Okay, so it looks pretty dry. Yeah, it's pretty dry on the inside, except for the little cracks. That's what I'm worried about. But I guess it's just a matter of how tightly I screw these in. So as you can hear, there's water running in the background, and I'm going to actually take a shower now. So I'll let you know how it goes. So as you can see, for my hair, I just showered, and this thing is just strobing. So, I mean, it's very wet. It got very wet. And this thing right here, yeah, that's pretty wet. That little, I mean, you can see the water, it's overflowing. So that's good. It's definitely gonna work next time. And yeah, it works. Now, I can shower think in peace. All while saving shampoo, coming out of the shower with clean hair and a head full of new ideas. I'd say that's a win-win-win. Come to think of it, people like Isaac Newton, Einstein, or Thomas Edison probably just sat in a room thinking in pure and tranquil quietness. No smartphones, no social media, no distractions. Maybe that's part of the reason why they were so great. So the next time you find yourself thinking in the shower, or the bathroom, or when you're bored, in a moment in time when it's quiet and shielded from the noise of the present, just know that it's productive.